Morning. So today's lesson we are looking at empirical formula. So empirical formula is the simplest formula based on chemical analysis of a compound. So it's not always specifically how we would use it as in terms of ions. It's more to do with masses, percentages. So there's certain steps that you would always follow. I've provided a help sheet as well, so have a look at the help sheet. It does the same steps, it talks you through exactly what I've done, so don't worry too much. You can copy your notes from there or look at that before watching the rest of the video and you can read that as I'm talking. So questions will always appear and it will always say empirical formula, so you know that's what you're looking for. So calculate the empirical formula of a compound that contains 88.8% carbon and 11.1% hydrogen. So step number one is you write out the elements in the question. So we've got carbon and we've got hydrogen. Step number two is you write out the number that's given to you in the question. So in this case, I've got 88.8% carbon and I've got 11.1% hydrogen. I know some of you will have spotted that doesn't quite add up to 100, but just roll with it for now. Next step, so step number three is write down the mass number. So the mass number of carbon is 12 and the mass number of hydrogen is 1. Okay. Step number four is you divide them. So you do 88.8 divided by 12. .4. And you do 11.1 divided by 1. Okay. The next step is you divide by the smallest. So you're going to do 7.4 divided by 7.4. And you're going to do 11.1 divided by 7.4. Okay. Now, at this stage, you will get one of three options. You will either get whole numbers, you will get 0.5, or you will get 0.3. Okay, so whenever you get an exam question, you should only be getting that at this point. So what we now need to do, we can't have 1.5 atoms of hydrogen, that doesn't exist. So we now need to times both of these by 2. You only do this step if you have not got whole numbers at this stage here. So we're going to times everything by 2. So that would make that 2. 1.5 times 2 is 3. So it gives us 3. So what we actually have, our final step, is you write out the formula. So we've actually got 2 carbons to 3 hydrogens. Okay, so that's the first one. That's a good example because it's got this 0.5 here. Something to point out is if you got something like this, you would take that as your whole number, so 1.0. So if you ever get 2.0 something, if it's ever got a 0 when you're on this bit here, take it as your whole number. Okay, if you wanted to have a look, we'll do another one here. This is going to test my memory of mass numbers because I've not got a periodic table in front of me. So this one here, calculate the empirical formula of a compound that contains 66.5% of copper and 33.5% grams, sorry, it's late, of oxygen. So copper, oxygen, so step number one, I write out the elements. Step number two, I write out the mass from the question. So 66.5 and 33.5. Okay. Step number, so that's step number one, that's step number two. Step number three is I write down the mass number. So copper is 63.5 and oxygen is 16. Step number four, I divide them together. Or I divide. Okay, so 66.5 divided by 63.5 is here's a good example at 1.0472. So 1.0472 and 33.5 divided by 16 gives us 2.09. 3. Right, at this point here, because we've actually got a ratio of 1 to 2, I could divide them, but all I'd be doing is 1 divided by 1 and 2 divided by 1. So I can do that stage if I want to. So just to show you for the purpose of this, I will. So I'm going to do 1.0 divided by 1.0, 2.0 divided by 1.0, which gives me a ratio of 1 to 2. So my answer would be CuO2. Okay, hope that's making sense. One more just to have a little go at. Okay, I just wanted to show you this one purely because it's got 3 elements in it. It's the same pattern every single time. So step number 1, I write out the elements. So I've got carbon, hydrogen and oxygen. Step number 2, I write out the mass in the question. So I've got 0.6, 0.15, 0.4. Step number 3, I write out the mass number. Carbon has a mass number of 12. Remember, you need to use your periodic table to get the mass numbers. Hydrogen is 1, oxygen is 16. Step number 4, divide them together. Next step, I divide all of them by the smallest. So my smallest one is this one here, 0.025. So I'm going to do 0.05 divided by 0.025, 0.15 divided by 0.025, and 0.25 divided by 0.025. So 0.05 divided by 0.025 is 2, nice whole number. 0.15 divided by 0.025 is 6, again a nice whole number. That one's obviously going to be 1. Lovely, I've not got any 0.5s or 0.3s, so I can just leave it as it is. So my final answer is C2H6O. Okay. There is a help sheet to go along with this because I am aware that this is slightly trickier. It's the same steps every single time though, so please don't email me to say you don't understand it. Follow the video again, look at the help sheet, look at the scaffolding sheet that I've attached as well. I have given you the answers on the next slide of the PowerPoint to the questions, so have a look at the answers. Obviously they will be clear which one is which because they have the correct elements in it. So if it says carbon, hydrogen and oxygen and you've got something that says sulfur, you know that's probably not going to be the right answer. So have a little look because the answers are on there. If you've not got anything that matches, go back and check. Have you written the mass from the question first? Have you then written the mass number? Have you then divided those together? Have you actually divided by the smallest? That's normally here where people go wrong. Have you then got whole numbers? If it's 2.0 something or 6.0 something, that is a whole number. You should have here either 0.5 or 0.3. Anything other than that is a whole number. You then write the formula out for the final mark. Hope that helps. See you tomorrow. Bye.